Okay, class, we're about to start section 2.6, solving equations, and the specific type of equations we're talking about are single-step equations. Remember back in chapter 1, we learned to decide whether or not a particular number is a solution to an equation. Example, determine whether -1 is a solution of the equation 3y plus 1 equals 3. Now, with these set of directions, it's telling us that y is actually equal to 1. Well, actually it's -1. Y actually equals -1. Now, what we want to do is take this -1 and substitute it in this equation here. So we will write the equation down. We add 3y plus 1 is equal to 3. Now we substitute in -1 for y. So we add 3 times -1 plus 1 equals 3. 3 times -1 is -3 plus 1 equals 3. -3 plus 1 is -2, and we know -2 does not equal 3. So our answer here is no. Okay, now we go down a little bit here. And it says here, so -1 is not a solution. But how do we find out what the solution is? That will be our goal over the next few sections. Consider the following equations. We had 3x equals 15. Can you solve this in your head? Okay, we know that 3 times 5 is 15. So for most people, we can solve that in our head. But remember, solving the equation means finding what number you could put in place of x to make the statement true. And we know x equals 5 would make this statement true. Now we look down here. Can you solve this in your head? I would say the majority of people could not solve this in their head. So this is where knowing the process will be valuable. So we move to the next page and we ask ourselves, how do we go about solving an equation without just doing it in our heads? There are 2 basic rules to follow. Number 1, do the opposite. Since your goal is to get x by itself, start by finding x and asking yourself what is being done to it. Then do the opposite operation. Here we have addition and subtraction are opposite operations. Multiplication and division are opposite operations. Number 2, whatever you do to one side, you must do to the other. With an equation, it is okay to make the equation look different, as long as the equation stays true. So let's say you start with the equation 3 equals 3. This is not a very exciting equation, but it is true. Let's see what happens if we subtract 5 on both sides in the first equation or add 5 to both sides of the second equation. But first of all, before we do that, let's discuss what sides are. When we say sides of an equation, that means the left side of the equal sign and the right side of the equal sign. The equal sign separates the equation. So when we say what you do to one side, you must do to the other, that means what you do to the left side of the equal sign, you must do to the right side of the equal sign, and what you do to the right side of the equal sign, you must do to the left side of the equal sign, which we will see down here. Okay, now we have our examples here. We have the equation 3 equals 3. Now in the directions above, which is not shown in this video, you can read the directions, but it tells us to use the number 5. So we have 3 minus, we will put 5 here, and also 5 here. 3 minus 5 is -2. 3 minus 5 is also -2. As long as both of these sides are equal to each other, the equation is still true. Now we look at number 2. This time we have addition. And as stated earlier, the directions above tell us to use 5. So we will put 5 here and 5 here. We added 5 to both sides of the equation. 3 plus 5 is 8, and 3 plus 5 is 8. So this equation is still true. So if you notice here, we subtracted 5 from both sides. It still made the equation true. We added 5 to both sides, and it still made the equation true. Now we have examples. It says solve the following equations. Be sure to document your solution by showing how you 1. Do the opposite, and 2. Do the same thing to both sides. Now let's take a look at number 1. We have x plus 6 equals 10. Now we have to determine first, what are we solving for? We're solving for x. Now you could do this in your head. We know 4 plus 6 is 10. But the most important thing here is that you get the process. So let's go through and solve this equation. First, we have this 6 added to the x. So we have to take its opposite to get x by itself. So the opposite of plus 6 is subtract 6. Now we bring down our x. 6 minus 6 is 0. So this would be x plus 0 equals 10 minus 6 is 4. Now x plus 0 is just x, and that equals 4. So our final answer here is x equals 4. Now I know a lot of you are accustomed to the language of saying this cancels out. Now what I want you to see is that positive plus 6 minus 6 actually equals 0. It doesn't just disappear. That would be very important later. But what we typically do, since we know that this becomes 0, we would just write x, because x plus 0 is x, and that equals 4. Now we go to problem number 2. We have x minus 3 equals 2. We're solving for x in this problem as well. So we need to get rid of this minus 3. And we get rid of the minus 3 by adding 3. Now we have x minus 3 equals 2, and we added 3 to both sides. So we bring down our x, and like we said in the previous problem, negative 3 plus 3 is 0. Since we know x plus 0 is x, we could leave off the 0 here. Now we have 2 plus 3, which is 5. So our final answer here is x equals 5. Now we go to example 3. We have x divided by 2 equals 5. Now we have to ask ourselves, what are we solving for again? X is correct. Now we have to look on the side that has x. Now this is x, and we know we call this a fraction bar, but this is really division. X divided by 2. So to get rid of this 2, we have to take the opposite on each side. Now we stated earlier that the opposite of division is multiplication. So what we need to do is multiply each side by 2. So we would take 2 times x over 2 is equal to 5 times 2. Remember, what we do to one side, we must do to the other. Now this 2 is really considered to be 2 divided by 1. Any integer, any number is basically still divided by 1. So now we have a fraction multiplied by a fraction. 2 times x is 2x. And then we do our denominator. 1 times 2 is 2. Now this is equal to 5 times 2 is 10. Now 2 divided by 2 is actually 1. So this would be 1 times x is equal to 10. 1 times x is equal to x, and that equals 10. Now again, this is another situation where I know a lot of you are used to saying the word cancel out. Like you would put lines through these 2's, and then you would just bring down the x. However, this divides out to be 1. That will be important later, so I want you to get into the mind frame that whenever you are canceling or simplifying, that you're actually simplifying out to 1 and you're multiplying it by this variable. Okay, now we look at number 4. We have 6x equals 12. Now we want to solve for 6. This x is connected to the 6 by multiplication. So we have to take the opposite operation, which is division. So we have 6x equals 12. And we have to divide each side by 6. Now, this is set up like the 2x over 2. But we don't have to write the 1. We know that this is really 1 times x, which is x. And 12 divided by 6 is 2. Okay, now we come to problem number 5. We have y minus 6 is equal to negative 2. Now we want to get y by itself. So since this is subtract 6, we will add 6 to both sides. So we bring down our y, and we know negative 6 plus 6 is 0. Y plus 0 is y. So we don't have to write the 0 here. So we have y equals negative 2 plus 6 is positive 4. Now we go to problem number 6. This time we have the variable on the right hand side of the equal sign. It doesn't matter. We still follow the same process. We find our variable. We need to get rid of whatever is on the same side as our variable. We have a plus 8. So we're going to subtract 8 on both sides of the equal sign. Negative 2 minus 8. Remember, when you have the same sign, you add them together and carry the sign. So this would be negative 10, and it equals. We'll bring down our z, and 8 minus 8 is 0. So we know z plus 0 is z, so we're done. It's negative 10 equals z. Okay, class, we go to problem number 7. Same thing. The variable is on the right hand side. What we do, like we did in the last problem, we would take 32 equals negative 8x. This is connected by multiplication, so we take its opposite operation and divide. 32 divided by negative 8 is negative 4, and that equals x, because this simplifies out to 1 times x is x. Now we go over to number 8. We do the same thing, except for the variable is on the left hand side. So we divide each side by negative 3. And here we have y equals positive 9. Because a negative divided by a negative is positive, these three simplify out to 1, and times y is y. So y is equal to 9. Now we come here to number 9. This starts off like one of the earlier problems we had. Since this is division, we will multiply each side here by 4. So it would be 4 times x over 4 is equal to 7 times 4. Now this 4 is really 4 over 1, so this will give us 4x over 4 is equal to 28. Now we know these 4 simplify out to 1, and 1 times x is x. And x is equal to 28. So we're done with problem number 9. Now problem 10 needs just a little bit more space. Okay, with problem 10, we have to multiply each side by negative 2 because y is divided by negative 2. So we will have negative 2 times y over negative 2, and is equal to 8 times negative 2. Put a 1 under this negative 2. Negative 2 times y is a negative 2y, and 1 times negative 2 is negative 2. And it equals to 8 times negative 2 is negative 16. Negative 2 divided by negative 2, a negative divided by a negative is positive, and these two simplify out to 1 times y is just y. And y is equal to negative 16. And you're done.